Hey folks, so today what we're going to do is we're going to finish up talking about absolute value equations with a few examples and some practice. Okay, so what I want you guys to remember from before is that we learned that the absolute value of -4, for example, is +4, and the absolute value of 6 is just 6. So what it does is it keeps positive numbers positive and makes negative numbers positive. Okay? Alright, so if we want to solve this, so we're going to get away from graphically now, and we're going to start doing things algebraically. Okay, we'll show a diagram to check that we're right, but I want to show what the solution to this is algebraically. And what you should have noticed in your reflection is that the two methods to doing this, so if we graph absolute value of x minus 2, we will recognize that that's what it looks like. Okay, so what you'll see is that one of them, so this branch right here actually has the equation x minus 2, and this branch right here has the equation, it's going down, so negative x, and the y-intercept's moved up to +2, right? So what that means is that this part is actually just negative x minus 2. Okay, so that's negative x plus 2, right? Because negative, negative. Okay, so the way that we're going to do this algebraically is we're going to do two cases, which you guys saw in your reflection, right? And case 1 is just going to be the right branch. So x minus 2 is 4, which means x is 6. It's one solution. And now we're going to do another case. And this one's going to come from the fact that negative x minus 2 is 4, which means negative x plus 2 is 4, which means that negative x is 2, which means x is negative 2. Okay? So x is equal to negative 2. Okay, and if I graph the line y equals 4, okay, you'll see one solution right there and the other solution right there, and they match up. They're 6 and negative 2. Okay? So you also saw that you always need to check if your algebraic solutions are correct. Right? So let's check x is 6. So on the left side and the right side, on the right side we have 4, right? That's already done. And on the left side we have the absolute value of 6 minus 2, which is absolute value of 4, which is 4. So that matches. Now let's check x is negative 2. Right? Well, on the right side we have 4, and on the left side we have absolute value of negative 2 minus 2. So that's x minus 2. So absolute value of negative 4, which is 4. So that's good. Okay? So our solutions, both of them, we double checked and they worked. Okay, so the main thing to recognize from this example is that there's always going to be our two cases, and one of them is always just what's in there, and the other one is the negative of what's in there. Okay, so let's see one more example. So here we're going to set up the same thing. So now I'm not going to graph it, but we'll do our two cases. So case 1 is going to be x minus 2 is equal to 0.5x plus 1. Okay, so what I'm going to do now is I'm going to move this over to the other side. I'm going to move that over there. So I'll have x minus 0.5x is equal to 1 plus 2. Right, so I move the 2 over, move the half x over. This gives me 0.5x. This gives me 3. And now to get rid of that 0.5, I'm going to divide, and I'll end up with x equals 6. Okay? So now let's do case 2. Okay? So now what I'm going to do is I'm going to do the negative of this. So negative x minus 2 is equal to 0.5x plus 1. So negative x plus 2 is 0.5x plus 1. Okay? So I'm going to do the same thing that I did here. Okay, I'm going to have negative x minus 0.5x is equal to 1 minus 2. So this is going to be negative 1.5x is negative 1. So x is 1 divided by 1.5, which ends up being 2/3. Okay? So what we want to do now is we want to check. Okay? So I'm going to check this one, and I'm going to do my left side and my right side. Right? So my left side says the absolute value of x minus 2, so the absolute value of 6 minus 2, and my right side says 1/2 x plus 1, so 0.5 x plus 1. So here I get absolute value of 4, which is 4, and here I get 3 plus 1, which is 4. So that works. Now is this one going to work? So I'm going to do absolute value of x minus 2, so 2/3 minus 2, and here I'm going to do 0.5x plus 1. Okay, so here when I do 2/3 minus 2, we get absolute value of negative 4/3, which is positive 4/3. Over here, we get 1/2 times 2/3 is 1/3 plus 1, which is 4/3. So again, it works. Okay, so far all of our solutions have worked out. Okay, so again, all we're doing is case 1, case 2, and check. Okay. All right, so let's try this last one. This one looks messy, but we're going to clean it up a little first. Okay, so what I want to do is I want to put all the absolute value stuff on one side and all the non-absolute value stuff on the other side. So I'm going to keep this 2 absolute value 2x plus 3, and I'm going to bring this absolute value over. So I'm going to subtract absolute 2x plus 3. Okay, and over here I have this 1, and I'm going to subtract 3x. Okay, now to simplify, if I have 2 of these minus 1 of these, I'm just left with 2x plus 3. Right? So now what we're going to do is we're going to break into our cases. So case 1. We have 1 minus 3x is equal to 2x plus 3. So that's that right branch, right? So let's solve that. I'm going to move the 3x over, so we'll get 2x plus 3x. And I'm going to move the 3 over, so I get 1 minus 3. So negative 2 is 5x, which then tells me that x is negative 2/5. Okay? So now let's do case 2. Okay, so we're going to have 1 minus 3x is equal to, now instead of 2x plus 3, I'm going to have negative 2x plus 3, right? So that's that other half of the branch. Okay, so I'm just going to simplify this a little. So that's negative 2x minus 3. Now I'm going to take the 2x, or I'm going to take the 3 over here just like I did the other time. So I have negative 2x plus 3, and I have 1 plus 4. So, or sorry, 1 plus 3. Apologies. So I've got 1 plus 3. So 1 plus 3. So I've got 4 is equal to 2x, negative 2x plus 3x is x. So I've got x is equal to 4. X is negative 2/5. Okay. So now what we're going to do is we're going to double check. Okay. So left side, right side. For this first one is, remember on the left side we have this whole thing. Or I'm sorry, we don't have to check here. We can check here because at this point we still haven't gotten rid of the absolute values. So this is where we're going to check. Okay, so you can check anywhere where you still haven't gotten rid of the absolute values. Okay, so on the left side we have 1 minus 3x, right? And on the right side we have absolute 2x plus 3. Okay, so let's plug in our x. So we get 1 minus 3 times negative 2 fifths, right? And that gives us 1 plus 3 times 2 is 6 fifths, which is 11 over 5. Okay, so on the left side we got 11 over 5. On the right side we have absolute value of 2 times negative 2 fifths plus 3. So this gives us absolute value of negative 4 fifths plus 3, which gives us the absolute value of negative 4 fifths plus 15 fifths is 11 fifths, which is 11 fifths. So that's good. Okay, so this answer is good. On the other side, so we're going to do the same thing, 1 minus 3x, and we're going to do 2x plus 3, absolute. So 1 minus 3x is 1 minus 12, negative 11, and over here we get the absolute value of 2x is 2 times 4 plus 3, 11. Negative 11 does not match 11, so that's no good. So this answer here, we strike. So here we just have that one answer. All right. Okay, that's it. So you guys can get to some practice now, and I'll see you soon.